Hello everyone again and welcome to the DMSI YouTube channel, and in here you guys have seen the title, and this actually talks about how to go from fraction to decimal. And in this particular video here, take note that this method is pretty much familiar with everyone, where through the conversion from fraction to decimal there are different things we need to take into account. Is what type of fraction are we actually dealing with, and based on what type of fraction we should be able to approach it through a lens that involves two of the three ways. Now, first is reviewing fractions involves understanding what it means. Usually, it talks about a form of real numbers, and this form of real numbers are usually either expressed as rational or irrational. Now, irrational numbers, we don't really care about those because irrational numbers, they don't, in this case, generate fractions, and so we are not going to be dealing with irrational, but rather we'll be dealing with rational numbers. And what are rational numbers? Rational numbers are numbers that are expressed as p over q, where 1 is that p and q are, in this case, integers, and 2 is that our q is not equal to 0. So those are the things to keep in mind. Now, looking at rational numbers, there are ways of expressing rational numbers. One is either through a type of fraction called proper fraction. Next one here is looking at improper fraction. And the final one here is focusing on the last one, which are mixed number. Is the combination of two things. One is we have a whole number plus we have a form of a proper fraction. And so these are the things to keep in mind in terms of types of fractions and how these type of fractions will determine what decimals are we focusing on. Now, improper fraction and mixed numbers, they relate definitely to each other, and our goal here is when given a mixed number, we need to be able to first convert it to improper fraction, and then once we're able to do that, we'll be able to, in this case, given a proper fraction, we can go directly to decimal by one particular method which we're going to talk about, and improper fraction to decimal through the same method. Now, this method here is known as long division, and through long division we'll be able to highlight this in detail. Now, let's look at a couple of things to keep in mind. One is the following. Remember when we talked about p and this is divided by q, there are terms we call them. The top number above the bar, the bottom of p, is known to be called a numerator, and the other number here, which is at the bottom, is called a denominator. And so once we have these two established, another thing we need to keep in mind is that based on what this particular bar represents, it represents a form of a operation which is called, in this case, division. And so therefore our numerator in this case, based on division, is called the dividend, and why the denominator is called the divisor. Now, these two can be used in many ways. You can use them not only in terms of integers, but also polynomials or binomials. All those are really interesting to actually explore in the future. So dividend and divisor will give you the following: a quotient and a remainder. Usually our goal is to be able to achieve a remainder that is equal to 0, but there are some cases where remainders are not equal to 0, and this is where we're going to explore this based on a couple of examples. So example 1, which I'm going to give you or us to address, is, let's say, a simple fraction which is 1 over 3, and this here versus, let's say, 6 over 3, and the next one here we're going to play around is one whole number, let's say 1 over 3. So looking at these forms of, I would say, rational numbers, our goal in this case is to be able to convert to decimal. And through this process, through long division, we should be able to accomplish this. You can do it on a calculator to confirm. However, we're going to use long division to be able to get our answers in decimal. So take note that in this case here, a couple of things to keep in mind when it comes to long division is the following. Long division involves this particular symbol, which is not a square root symbol, I know, but it's just a kind of a L, but rotated 90 degrees, to the clockwise. Let's put it that way. So in this case here, there are a couple of areas to be aware of. This area of this particular sign is called the divisor. The number that you have on the divisor or as a divisor has to be the whole number. All the numbers, that's what I mean. All the numbers I count as one number, and that is a divisor. Now, the other number that or area of this on this particular color sign that you should be aware of is this particular section right here. And this section here is called the dividend. And this dividend is what is going to be divided by the divisor. Now, the dividend, we usually go one digit at a time from left to right until we're able to get all the dividends completed digits wise. And then this other section of this particular diagram is called the quotient. And this quotient is the answer that is pretty much the factor that you are getting. And so the quotient is going to be determined and placed in that particular position. And then the final part is where the remainder is going to be positioned. And our remainder is going to be positioned after an operation is established, which is in this case a subtraction method. So through subtraction of our dividend and our product of the quotient and the divisor, we'll be able to get our specific value, which is called the remainder. Remember that as always, our goal is to be able to get our remainder to be equal to 0. There are some cases our remainders won't be equal to 0, and those cases we'll address in this example. So that is the basics here for long division. So the other basics here is that our dividend, we go one digit at a time in terms of following these particular operations. First is for the first digit, we go dividend digit divided, not multiplied at all. So first step, let's change the color here. We'll go steps as follows. First is we perform division between our dividend first digit and the whole number in the divisor, and the next step is to multiply, or that is, this division gives us the quotient, and then multiplication is in this case multiplying our quotient digit by the divisor to get our number, and that number we perform subtraction from the dividend digit that you perform the operation with, and finally you get your remainder. And then it goes on and on. Division, multiplication, subtraction, as you move from one digit to the next on the dividend area until you arrive at the final answer. So let's perform this with our first question. Our first question here is where you have this fraction, which is in this case 1/3. Take note here that this, which is the numerator, is the dividend, and the bottom here is the divisor. And so therefore, in this case, when we have our symbol, we have our dividend and we have our divisor. Dividend in this case is we're performing division first, 1 divided by 3. not up to 3 in this case for our divisor. So we have 0 remainder 1. Now how is the remainder going to be revealed? 0, which is our next operation. 0 times 3 gives you what? 0. And so we perform our next step, which is subtraction, and we get 1, which is our remainder. Now we are not done here. We need to get more out of this because we want our remainder to be equal to 0. So what we do is you put your decimal point, and right below the decimal point you add a 0 to our 1 on the right side of it to make the full digit here 10. So in here we have a new number, which is 10, and 10 is going to be our new dividend that we are going to divide by our divisor, which is 10 divided by 3, which gives you what? 3 remainder what? 1. And where does that 1, how does it come into play? To get that 1 remainder, we perform 3 times 3, that gives you 9. Subtract 9 from 10, and you get 1. That is your remainder, and then you go on and on again. So in here we add another 0, and you're like wondering, this is going to repeat again. We're going to do the same thing. If you observe what is happening, we're saying that the 3 is going to show up, and 3 times 3 gives you 9. This repeats again, and this repetitiveness, when you subtract, shows you that these particular digits after the decimal point is just going to continue. 3, 3, 3, 3, 3, 3, 3. So this repeats after the decimal point. We usually put a bar at the top of the 3 that is repeating, and that is our answer. So the decimal of 1 over 3 is 0.33 as our specific answer right here. And so that is how we're able to approach this question in terms of converting from fraction to decimal through long division. And the next one here, don't forget subtraction, which is our final step. Now, the next one here is dealing with 6 divided by 3. So in this case here, there are different ways of approaching this question. You can actually draw 6 circles and create groups of 3. In this case, our answer will be revealed. Or you can actually go in the long division route. So you have 6 divided by 3. We have this to be our numerator and this to be our denominator. Therefore, this our numerator is called the dividend, and the denominator is called the divisor. And in this case, we should be able to arrive at the answer that you guessed it is. And in here, based on the positioning, our dividend is going to be in this particular position here. Our divisor will be in this position right here, which is 3, and we begin from there. First step, division between dividend and divisor, and 6 divided by 3 gives you 2. Then next step is quotient, which is obtained, times the divisor, that gives you 2 times 3, 6. But from negative subtraction, 6 and 6, and that gives you 0. Boom, you're done. And in here, our answer here is 2 is the answer. Or you can continue if you want. You can add a 0, and put the decimal. Well, technically we put decimal first and add a 0 at the bottom. So next step is 0 divided by 3 gives you 0. 0 times 3 gives you 0. Subtract, and that still gives you 0. So in here, we have shown you that whole numbers can be expressed as decimal. And in here, this is our specific answer to this question that shows you that, hey, 6 is a multiple, of 3. So that is something to keep in mind right here. And finally, we have the strange one, which is one whole number 1 over 3. And how does this look like in terms of how to approach long division with something that is from a mixed number. Now, a couple of reminders here. The reminder is as follows. Where we have a whole number 1/3, in this case what we have to do is as follows. Either you break 1 into units of 1/3 and then you collect them together, include your 1/3 to give you your answer, or you go through the short method way, which is, I usually call it 3 times 1, and your answer you add 1 to it. And so in this case, 3 times 1 gives you 3, and 3 plus 1 gives you 4. Therefore, we have our 4, which is our new numerator, divided by our 3, which is the unit fraction. So therefore, once we have this as our new value, we can then proceed to the next part, which is as follows. We have this to be our dividend, and here to be our divisor, and therefore we can proceed to positioning them on our division framework, put it that way, where we put our dividend and our divisor, and so therefore we can proceed from there. First step, division between our dividend and divisor. Dividend divided by divisor, 4 divided by 3 gives you 1, and remember there's a remainder 1. That remainder 1 comes into play where you multiply, which is next step, 1 by 3, that gives you 3. Then you perform your subtraction, which is our next step, 4 minus 3, that gives us our remainder 1. And then the next step here is put a decimal point next after our 1 and add a 0 at the remainder end after 1. And so we have 10 now as our new dividend. And so 10 divided by 3, which is the next one, which is what? 3. We have 9. We've multiplied 3 by 3. And to get our remainder, we subtract from 10, and we should get 1 at 0. And this repeats again. And so, based on this particular sequence that we see again that reoccurs in this particular example that we performed right here, we can conclude that the quotient is going to repeat after the decimal point 333. And it's quite interesting to see this again plays out in this particular question. It's not a coincidence, it's just the way it is. And so this here in conclusion gives us our specific decimal of this, putting our bar, of course, because it repeats, to be equal to 1.33333333 and goes on and on until eternity. Anyways, that is how we're able to express long division in our way to convert from fraction, specifically proper and improper fractions, through long division to decimal. And I hope you found this really informative. If you want more information, you can check my website. We actually have notes that are nicely presented for you to understand, and so that way I can talk to you soon. Don't forget to subscribe, and by that way I can see you next time. Stay smart as always and believe in yourselves.